All right, welcome to the first video. This one is entitled You Pi Are Completely Irrational. And we're going to do some defining rational and irrational numbers here. One of the things that I'm going to put in a lot of these videos is here's our Common Core State Standard. It is 8.NS.1. You can read that. You don't need to write all that down. You're more than welcome to if you want. I would just ask that you write down 8.NS.1 at the top of your notes, and that you keep that as the heading, and hopefully you can just sort of keep that each time. We'll refer back to the notes by the standard that we're covering. Okay, so here it is. Let's move on. Okay, so first, we've got this thing that are called real numbers. Now, I don't know what you know about real numbers, what you don't know about real numbers. We've just met. I'm still trying to figure out how and what it is that you do know about math in general. So I'm going to probably get maybe a little overly basic here. Bear with me. So you probably know that there are certain types of numbers. We have whole numbers, right? Those are just your regular counting numbers. We have integers and we have rational numbers. Now, maybe I really hope you've heard of integers. Rational numbers, maybe not. Okay. So let's kind of go through these real quick. Let's see. There we go. All right, whole numbers: 0, 1, 2, 3, 4. We might call these counting numbers. Pretty basic. Integers. Okay, so these are the counting numbers that also include negative numbers. So they go up, they go down. -3, -2, -1, 0, 1, 2, 3. Pretty much anything that's a whole number that also is positive or negative. Okay, now we have this thing that's called rational numbers. Okay, and this is where I'm guessing many of you have, maybe you've heard of them, maybe not, but I'm going to talk to you like you've never heard of them before. Okay, so a rational number is a number that can be written as a ratio of integers in the form of A over B. Okay, you can write it as a fraction. Sometimes you'll hear people say that it's a quotient of two integers. Okay, now a quotient is the answer to a division problem. So if I have integer A, whatever A is, right, it just means A is an integer of any type and B is an integer of any type. If I can write a number where it's two integers above and below each other, totally fine rational number. Okay, and hopefully you're sort of thinking here, well, can't all numbers be written like that? You'll see what I'm talking about. So for your notes, you might want to put in this previous slide of whole numbers and integers. If you already feel like you got a firm grasp on that, don't bother. If you the integers part, maybe you're like, well, not so sure, then put that in there. I definitely would write this rational numbers. Okay, I'm going to expect to see this in your notes when I check them. Okay. If you've never watched a video for a class before, I would encourage you to pause, rewind, review, listen to it over and over again. Some of the strategies that some of the students would use with these are sometimes they would watch the entire video without stopping or taking any notes, and then they would go back and sort of watch parts of it again and take the notes that they thought were necessary at the end. Some students like to just go right through. They'd start the video, they'd write down what they needed to as they went, they'd pause when they needed to, and that's how they did it. So I encourage you, whatever works for you, try a couple different ways, whatever you think works the best for you, keep doing it. I would just want all of your notes in one place together. And the whole idea of the videos here are put them online for you, then they're there for you all year. You don't need to continuously ask me, Mr. Clark, I forgot how to do this thing. Here you go, ready for you. Good? All right. So let's move on here. Let's pick a couple of rational numbers here. We've got 1/2. That's a rational number. Okay. Then we have two integers in a fraction, or it's a ratio of two integers. That's rational. 0.3 repeating, right? That's what that little bar over it means. This is a repeating bar. This means 3 goes on forever. Okay, that's the same as saying 1/3. Hopefully you already know that. If you didn't, then hey, there's 1/3. That's two integers, right? 1 over 3. 1 is an integer, 3 is an integer. That's rational. 3.25. Well, that's 13/4, right? You might have said, whoa, well, that's 3 1/4 or 3 25/100. But remember, the rational number is just a fraction, okay? It can be an improper fraction, and I'm not sure if you've dealt with this a lot, but a lot of times improper fractions are the best way of doing something, okay? Sort of spoken wrong. They're not really improper. Oftentimes they are the best way of talking about things. So this one would just be 3.25 is 13 quarters, okay? And that's also rational, okay? Because I can write it as an integer, two integers as a ratio. Okay, so here's some the same rational numbers, and they're written in a different way. Okay, I wrote them out in decimal expansion. So what I want you to do is what do you notice about them? So I want you to pause the video here and think about what do you notice about them, and then what else do you think we can say about rational numbers. So go ahead, look at those, see if you can find a pattern. Okay. All right, hopefully you had a little bit of time, and I'm hoping that maybe you looked at that and said, wait a second. On all of those, there's something that repeats, right? Like on this one, it's 0.5000000, and I don't need to keep continuously placing zeros in here, right? The zeros are actually what are called placeholders, right? This is, each of these represents a different place value. The 0 is the number of ones that this number has, right? Well, it doesn't. It's less than a whole. So I don't have 1, but I have 5 tenths, and I have 0 hundredths, and I have 0 thousandths, and 0 thousandths, and all the rest of these are 0 as well. And so we don't need to put in a 0 for those. We usually understand 0.5 is sort of the end, right, or 5 tenths, but those zeros actually are in there, and they continue on forever. Well, the same thing is true here, right? 0.3 repeating, well, this is 3, 3, 3, 3, and it goes on forever and ever and ever. And again, here we have 3.25 and the zeros, and they go on forever. And so a sort of shortcut way of saying this is what we're saying is rational numbers repeat, okay? Sometimes you'll see that people will say rational numbers, they either repeat or terminate. I'm trying to break this down for you. If it repeats, it's a rational number, okay? If the number looks like it ends, well, then it's technically repeating because the 0 is repeating after it. Okay, there you have it. All right, so this is what we've got so far. Okay, if you this box here, this general overall box, this is sort of all of the real numbers that we've talked about so far. Okay, we've talked about whole numbers, right? And whole numbers, this is a set of numbers which are included, right, in this bigger set of integer numbers, right? Integer numbers are all the whole numbers and their opposites, so and all the negative numbers that go with it, okay? And then what rational numbers are whole numbers, integers, plus all of the other numbers that are fractions that aren't whole numbers, right? Like a regular whole number like 3. I can write 3 as 3 over 1. That's a rational number because I've taken 3 and I've turned it into a fraction or a ratio of 2 different integers. Okay, well, there's more. There's a bigger picture, okay? This idea of real numbers includes all of these so far, but there's another part of this, okay? So what I'm asking here, are there decimals that don't eventually repeat a pattern? I'll say that again. Are there decimals that don't eventually repeat a pattern? Okay. So just think of one and see if you come up with one, maybe bring it to class and we can talk about it a little bit. But the most famous of them all is this number of pi, right? And pi is, it's not really a number, it's sort of an idea, but we represent it as a number oftentimes. 3.14159, blah, 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 and on and on and on and on and on, right? But it never repeats. It continues on forever without having any sort of repetition to it. And people have been studying pi for an extremely long time and memorize its crazy amounts of digits. No pattern, okay? None has been found. So, this is an example of a number that doesn't repeat, okay? What about this one? Square root of 2, all right? Looking to see what number multiplied by itself will equal 2. Well, you have to break it down and keep going and going and going. And what you're going to get is 1.41421, blah, 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 and on and on and on without any repetition. Again, no repeating pattern. Here's another number, 7.71, 711, 7111, 7111. No repeating pattern, okay? And we'll talk more about this. If you have a problem with that, bring it to class and we'll talk about it. Okay, so these don't have any pattern. You don't have a partner right now. We will share and talk about this in class, okay? But I do want you to think, why isn't that a repeating pattern? Okay, if you had a problem with that, think about that, bring it to class. Okay, now, since numbers that eventually have a repeating pattern of digits when written as a decimal are called rational, we have these ones that if they don't repeat, if there's no sort of pattern to it, then we call them irrational. Okay, and now we have a larger picture of this idea of what are called real numbers. We have rational numbers and irrational numbers. Okay, the rational numbers are the ones that we put in here. 4, okay, that's a whole number. Well, and then integers, right? Well, that includes -7. Well, 4 is also an integer. That's why it's inside this box here. And then 7, -7 is not a whole number, but it is an integer. Okay, now 4 and -7 are both part of rational numbers. Okay, but 0.3 repeating, or 1/3, is not an integer, nor is it a whole number, but it is a rational number because I can write it as 1/3. Okay. Then we have all these other numbers over here, the square root of 2, pi, this weird 7.71 crazy number. Those are irrational, right? They cannot, there is no pattern to them. We cannot write them as a fraction. Okay. So these are altogether these things called real numbers. Okay. And we'll talk a little bit more about this. We'll talk about identifying them. We'll play a couple of, I got a couple of activities we can do to get better at this. And you guys will be incredible. You'll be able to rock it through these. All right, so here's what I want you to do. This video is probably about 12 minutes long. Maybe took you 20 to write everything down. That's about average, I would say. This one is pretty basic, I think. Pretty informational. Not a lot for you to do in it. So, but bring these notes to class. I'm going to check them in at the beginning, and they are a large part of your work completion grade. So make sure you keep up with these. And you can always use them to refer back, and when you get stuck on a problem, I oftentimes will say, well, did you check your notes? Did you look? Because they're your notes. They help you understand and learn the topics more clearly. All right, bring them tomorrow. See you then.